Good afternoon. My name is Mia Reyes. I am on the foundational security team in the Security Compliance Identity Organization at Microsoft. My colleague, Richard Diver, is here in the room as well. So we want to say thank you all for coming to one of the sessions that we are putting on with our esteemed experts and colleagues up here. So very quickly, the foundational security team, we are the team that thinks about, cares about secure by design, secure by default at the company in partnership with all of the engineering teams and all of the marketing teams and all of the product teams. So we're all about defense in depth and shift left. And one of the big things, obviously, for our team is thinking about secure software supply chains. And so that is why we really wanted to bring developer security and all of the things that come along with developer security, like the secure supply chain consumption framework, to build and to the developers here. So thank you all for joining us. I will say, before I introduce our panelists, our hosts, our guests, we are a hybrid event. So for those of you that have not been on a hybrid event yet at Build, we do have folks on the call. If you want to participate in the chat that is happening, if you go into the Build event scheduler, on today's session, you can just search either Adrian or Jasmine, or search secure supply chain consumption. You will have a Teams link in there. You'll just be able to open up the Teams link on this session, and you will join all of our colleagues that are already on the call. You'll see we have 100, we're getting close to 90 plus folks that are already on there. We're going to be monitoring the chat, myself and Richard, but we welcome you to kind of jump in there as well. So today's event, like I mentioned, is hybrid, and it's really meant to be conversational, right? So our guests and our panelists are going to talk for a few minutes, but the real purpose of this is for all of you to have a conversation with them about the topic. And so we're going to talk for like 10 minutes, 15 minutes, 20 minutes, however much Adrian and Jasmine do, and then the rest of it is pure conversation. So really, really encourage you in the room, please. You can post questions in there, or if you're in the room, Richard and I, we can just moderate. Just raise your hand at the end, and for those on the call, we are also going to be moderating, making sure all of you get in on the conversation. We'll raise any questions in the chat to Adrian and Jasmine as well. So I just want to introduce Adrian Diglio, Jasmine Wang, who are here to talk to us about the Secure Supply Chain Consumption Framework. Adrian and Jasmine are experts on the security engineering side who work on secure software supply chains. So on that note, I will hand it over to our.
Thank you, Mia. So I'm Adrian, and I'm here to introduce to you the Secure Software Consumption Framework, otherwise known as S2C2F. I think that acronym kind of sounds like R2D2 a little bit. So S2C2, R2D2. I happen to like that acronym. If you don't like it, you can just call it the consumption framework. And this is all about, it's very, very focused, and it's all about how developers consume open source into their workflows today, and how can we improve the security of that to protect our software supply chain. As we go through this talk, I'm going to be talking to you about the threats to developers, and then how the S2C2F can be something that your dev team or your entire organization can plan to adopt to walk through requirements and help you improve your maturity and your defensive posture against supply chain threats specific to open source. So, Synopsys published an annual report, and they noted that 98% of modern software today has open source inside of it. And if you do your own searching, you'll see that there's other similar reports, and they're like 96% or whatever. Generally, I think we can all agree that a lot of software runs on open source. In addition, there are other reports out there that state that approximately 80% of the code in any modern application today is comprised of open source, whereas the other 20% is your own original code that you've contributed. So not only is it like vastly used across this entire software industry, but it also makes up a ginormous chunk of what comprises our modern applications today. So when you think about how much open source is used, and then you look at, well, how often is it under attack? Sonatype publishes an annual report every year called The State of the Software Supply Chain, and it's very focused on open source. And as you could see, they've actually noticed a 742% average growth rate year over year on attacks specifically targeting open source. With last year having over 88,000 malicious packages discovered. So what is a malicious package? It's usually a compromised package where somebody sneaks in a back door where it'll exfiltrate environment variables back to the attacker-controlled system, or it'll exfiltrate your authentication tokens back to the attacker so that they then can compromise your environment and your development infrastructure. Software supply chains, in essence, is attackers have been shifting left. They are now targeting developers, developer identities, and the engineering systems that developers use, like DevOps platforms. And they're using open source as a way to sneak in. So with those two things combined, how extensive open source is being used, and how much it's under attack and growing under attack, open source is arguably the most important aspect of any software supply chain. And Microsoft is no exception. Microsoft loves open source. We are a large consumer of open source. 83,000 unique packages used across all of our code bases, and used more than 11 million different times across all of our repos and projects. And it's because of this extensive usage that our team got started on this journey to secure how we consume open source back in 2019. So we started implementing this back in 2019. It all started with a strategy doc. And then as we matured ourselves and matured our own processes and learned from this, we then published it as a framework that any development team or organization can adopt themselves. And we published it just last year, and then we contributed it to the Open SSF. That's a Linux foundation, stands for Open Source Security Foundation, and it's a neutral place where our industry peers can all come together and work on the problems that affect all of us, which is the security of open source. And not only did we just contributed it, we now lead and maintain it within the OpenSSF. We have bi-weekly meetings where we continually to review new threats and make sure that the S2C2F framework is designed to help protect you against all the different threats that exist today targeting open source. So what is it though? Like let's just zoom in a little bit. It's a set of requirements, and we've organized those requirements into a maturity model with 4 different levels. And Jasmine's going to talk a little bit more about that in a few slides. And it's all about how you can improve and securely consume OSS into the developer's workflow. And what OSS am I talking about? Specifically, the ones used by developers like NPM, NuGet, Maven, PyPy, Rust crates, Ruby gems, and Golang. Those are the things that have been under attack the most and are getting pulled into developers' environments, compromising workstations, compromising builds, and we as an industry can do better to protect ourselves against these sorts of things. And this framework can help you do that. The S2C2F is very, very focused on just the consumption piece. It does not tell you how to securely produce software. There are other frameworks for that. So the S2C2F pairs very, very well with producer-focused frameworks like NIST SSDF, or the NSA Enduring Security Framework, or the OpenSSF SALSA framework, or the Center for Internet Security, and I happen to be wearing their socks. So why does this matter to you? It's something that any developer team can adopt, and they can follow these steps. And because it's organized in a maturity model, it helps you figure out what to prioritize first and then work on next thereafter. So let me back up a little bit and show you the big picture. By the way, our team recently just published a blog about this. If you want to search about the journey on how Microsoft secures our software supply chain, we explain this in more detail. But let's take the complex and simplify it for you. So we've organized this into 3 horizontals. The first horizontal is the producer. So if you are a software producer, you have source, you have build, and you have releases. And those are the things that you do in your DevOps workflow to ship software. But also as a producer, you are also a consumer of open source. You pull down things off the internet and rely upon them in your production systems. And then furthermore, if you think of these 3 horizontals as your DevOps platform, you have to also think about the accesses that are there, devices and identities that have access to all the different things that can change settings. Because when an attacker gets into your environment, they're going to then pivot inside your DevOps environment to figure out what they can change, how they can manipulate your software, all because you accidentally consumed a compromised OSS component. So at Microsoft, we follow the SDL. We've been using the SDL since 2004, published it in 2006, and it's been evolving ever since then. It's been adjusting to changes in software development processes, like in adopting to Agile methodology, and it's also been, requirements have been changed and modernized in accordance with new technology such as AI, ML, and the cloud. And now most recently, we've incorporated all of our software supply chain security requirements into the SDL as well, because this is all about how Microsoft continues to build in security and trust into all the software that we ship. And then here's the S2C2F. This is the framework that you can use to secure how you consume your open source in the developer workflow. We also use zero trust principles in order to secure access to our DevOps platforms. This is things like phish-resistant MFA, conditional access, principle of least privilege, and just-in-time administration for admin-level tasks within a DevOps environment. And if you think of this whole kit and caboodle wrapped up, you also have to be concerned about the secure configuration of your DevOps platform. You should have security monitoring in place to look for anomalous events in case an attacker does get inside your environment. Why is somebody searching for secrets in source, like through all of your repos? And then additionally, you should have incident response and disaster recovery plans in place as a just-in-case measure. And so the reason why I wanted to show you this is to show you the big picture and show you where the S2C2F fits within the larger picture. Now I'm going to hand it over to Jasmine.
So let's talk a little bit more about the S2C2F specifically. We start with 8 high-level practices, and this starts at ingest, and on this diagram we go clockwise all the way around. And these are high-level practices that are more suited towards CISOs, Chief Information Security Officers, people like risk managers, and anyone just looking to build their overall OSS supply chain strategy, because these more so describe the jobs to be done and less so about the exact implementations or the how of how you should be achieving these practices. But each practice does have specific requirements that map to each of them, and this goes more into the implementation, like nitty-gritty, so the how of achieving this. And this is more so suited towards developers, engineering managers, and other security practitioners. In addition to that, every requirement that we wrote up was actually based on real world scenarios and real world threats and how we would mitigate those, which I'll talk a little bit more about in the next slide. So this table, very large. You can see it yourself in our guide and download it, and we won't be going through all of it today. But as you can see, it describes specific threats, some real life examples and scenarios that you may recognize, as well as the mitigation that it specifically maps to in the S2C2F. So if we look closer at the first one up here, salt stack, which is accidental vulnerabilities in OSS code or containers that we inherit. It lists the mitigations from the S2C2F that can be used to mitigate that risk of that incident and which requirements that they map to. So these specifically map to two requirements in the updated category. Again, we're not going to go through all of these, but you can look at it in our framework at your leisure. So also in our framework, we have something called the maturity model, and this goes from levels 1 through 4. Each level has its own theme to it. So level 1, having a minimum OSS governance program. If you're using a SCA scanner or a software compositional analysis scanner, as well as a local package caching solution, then you will have already achieved this. Level 2 is all about improving your patching speed. Level 3 is about preventing accidental consumption of malicious or compromised packages, as well as doing proactive security reviews to detect 0 days. And level 4 is more of an aspirational North Star. It's very difficult to implement all of these requirements at scale, but it is very feasible to do on your most critical dependencies in your most critical projects. So as you can see here, under each level, we also have the requirements listed that correspond to each of these levels. We're not going to go through all of these, but we can talk about one specific one in level 2. If you look at the third bullet down, auto OSS updates. So that requirement essentially talks about having some kind of an automated way to patch your OSS known vulnerabilities or known malicious or compromised packages. A mechanism that exists today is Dependabot, which is available on GitHub, and that essentially creates automatic PRs that just patches it pretty quickly. And for each of these requirements in the framework, we also have listed free or paid tools that can help you implement these at your own team or organization in your projects. So earlier, Adrian talked a little bit about how we've contributed this framework to the OpenSSF. In that, we also have our own special interest group within the OpenSSF, and so you can join us and help contribute to this. So some of our goals of the framework and our special interest group is to increase awareness of the framework itself, to engage with the community, make sure we get those broad perspectives and integrate those into our framework to make sure the framework stays as up to date as possible, increasing adoption of the framework itself, and also driving tooling innovation. Today, we're achieving or working towards achieving those goals by assessing new OSS threats as they come in and make waves in the industry. We make sure we assess our framework where it stands today and see if we need to add any more mitigations or clarify anything. Developing reference implementations for each CI/CD platform. We're also in the process of creating a course as part of the SKF, the Security Knowledge Framework. And we also have potential for international standardization, pursuing that through ISO. So what can you do today? You can download or read the guide. It's available on GitHub at this link. You can also assess where your team or organization stands today. In terms of our 4-level maturity model, we have an assessment available in the guide. You can join our SIG community meetings within the OpenSSF. You can find all the information on the OpenSSF's Google Calendar. We meet once every 2 weeks. And you can also just start integrating tools that we mentioned in the guide into your projects today. So I hope you'll consider adopting the framework for your use. Thank you. We have time for questions and discussion.
Is a hybrid meeting. Since this is a hybrid meeting, I am going to have to be the person that asks you if you have a question to ask it into the mic. So all of the folks, we have over 200 folks on the call as well, so I want to make sure that they can hear the question. But here's an incentive. Richard Diver, my colleague, has very rare swag. He's the only one who has a bunch of security branded stickers and security branded stuff. The only one in Seattle, Washington that has it at Build. So if you're in the room you get Richard's lovely swag. So I have somebody here to start. I'm going to pass the mic.
So how do we scan NIST 800 controls part of the GitHub? Do you guys have any actions from the Microsoft or Azure? Because right now we are struggling to do that in government.
I'm going to get out of this. I'm going to stop sharing and go directly to our framework. Oh, we have to reshare. We're gonna stop sharing and reshare. So in our S2C2F guide that you can download, at the very end, we've actually mapped and traced our requirements to 6 other frameworks so that you could say, if I'm doing this, I'm also meeting this other requirement, like from NIST. So here is our, here we go. I'm going to read it in Markdown. And I think we have the, it's in the appendix. So you could see here that we have our, all of the various requirement IDs, and we've mapped them to 6 other framework requirements: 800-161, 800-218, the Center for Internet Security, to OWASPs, to SALSA, and to the CNCF Software Supply Chain Best Practices. And so you could see how each one maps to each of those.
I don't see 53, right? 853?
Correct. 853 is a very, very broad set of requirements. I'm mapping to supply chain focused set of requirements. I would actually say that there's very few 853 requirements that apply to like the development environment. 853 is very much focused on the production services that are running. If you look at 800-161, which is the SSDF, Secure Software Development Framework, they also map to 853 controls. So there's like a second level of mapping there.
So these can be scanned using your actions. Do you publish any actions in the GitHub space? So we can just call your action, that would scan automatically, right? Is there anything like that?
So what this framework is calling for is like a concert of tools that help you achieve these various requirements. So as you can see, this is the implementation section of our guide. It's organized by maturity level 1, 2, 3, and 4. And so you can see that this update 2 requirement about automatic patching of OSS, that can be achieved through tools such as Dependabot or Renovate. And we're looking to continue to enhance the list of tools here, but these are tools from across the industry. It's not just Microsoft tools. It's open source and also like enterprise apps.
Yep. Here. Okay.
Yes, sir. And then you're next. Okay.
So as a matter of fact, specifically about automatic patching, a lot of people in the software development community are averse to even regular patching and until they're really kind of required to do it because they don't want to break functionality and things of that sort of stuff. So what's your general kind of talk track about how we manage that and how we keep moving forward?
Yeah. Fantastic question. I love it. Yes, there will always be some open source components that require planned work to update. Those will likely, you'll just not accept the PR that Dependabot sends you, and you'll have to just plan that one out. But for all the others, where if your team is good at maintaining your hygiene and you can just simply accept the PR, you're going to be in a much better place. And now I'm going to get to my talk track. So Jasmine earlier talked about the salt stack vulnerability. The thing that was interesting about that vulnerability is it came out in 2020, and they announced the CVE at the same time they said, here's the patch to fix it. That's the right way to do things. Attackers researched that vulnerability crafted the exploit for it, went and found systems in the wild that were still unpatched, and started actively exploiting systems with the vulnerable version within 3 days after announcing that CVE. 3 days should be every organization's North Star for how fast you patch, because that is how you can patch faster than the adversary can operate. And I'll give you one other example to make it even scarier. There were 3 remote code execution vulnerabilities, all involved with open source. The Omigod RCE, the Log4j RCE, and then the Spring4Shell RCE. And a little known fact is that the Mirai botnet and another botnet, I can't remember its name, automated exploits at scale to continue to grow their botnet. So we are up against adversaries that are now working incredibly fast to craft exploits, and also up against botnets that are just constantly attacking us at scale with automated exploits. So patching faster should be a core mission of every software development team.
Okay.
That's my talk track about that.
I got one. We got a question from online. So Adam says that he thinks the largest challenge for small organizations is local governments to move forwards with the challenge of security. So how do you recommend in the framework to implement it with limited staff? How do we get started, basically? How do we
get started? Okay. So in our framework, I'll try to scroll back up to our, and here's our list of requirements. We also have a nice little how to assess where your organization is in the maturity model. So that will help you figure out how to get started. So I highly recommend you come to our repo and you check out our guide. It's available in Markdown or PDF. And so it gives you a bunch of questions here. I think it's over 20 questions that you can start asking your developer team what their software open source consumption practices are. That would be a great way to start. But I would also say that this is where every organization should focus. And I think the rule of thumb in the past was scan your open source for known vulnerabilities, have an inventory of the open source, and then update it. That was every organization's governance program for the last 10 or 20 years. We made that level 1. That is now just the bare minimum. And we are advocating that organizations take steps to improve your maturity to do things faster. And so I would, for that question online, I would say assess yourself where you are on the maturity model, and then begin analyzing what other sort of tools could your teams potentially adopt to help meet these requirements. Sir.
Hi, thank you. On the artifacts, so we've talked about bringing them down to a local repository. What sort of processes do you recommend in terms of, say, pre-scanning, so you don't accidentally bring down something which then gets picked up quickly because everyone's patching quickly? What's that feedback loop?
Great question. I'm going to actually go back to our slides. It's okay. I think we can do this. You were sharing your screen, right? No. Okay. Okay, can you please reshare? So what's interesting is that developers are very creative at how they bring in open source into their project. There are a myriad of ways that developers consume open source. Yeah, can you please jump all the way to the appendix slides? Here we go. So some people pull them directly off the internet, direct from the public package managers. Some people check in the package directly into source control. Many times developers will use curl bash, wget, invoke web requests and start pulling in their open source. Git clone is another one. There's copy and paste of code snippets that people do and put that code side by side with their own code. Private forks. Sometimes we've even seen people bundle it all together in a zip file and check that into their repo. And then there's also, consuming from the public package registry into a package caching solution like Azure Artifacts inside ADO, and then consume that into your build. That is the one that we actually recommend. And I can tell you a story about how we've done this inside Microsoft. And the reason why that's a problem is, how are you supposed to control the supply chain if there's no consistency? This is what the ingest practice is all about. We really need to focus on how developers ingest packages and make that consistent so that you have a controlled ingestion process and make sure that all your open source is being consumed in that way. If it's okay, I'm going to continue on this line. Am I answering your question or? Okay, great. Okay, so this gets into how do developers set up how they consume open source. So for all the different packaging ecosystems, there's a thing called a package source file. This is like a NuGet.config, an npm-rc, a pip.conf. And so I'm going to show you how to recognize an insecure package source file with one example. I'm going to use a NuGet.config. In this example, you can see that there are 3 different locations where this developer wants to pull their packages from. One is direct from NuGet. The other is from their local desktop. And then the third one is from an Azure Artifacts feed. Now, the reason why this first one is an issue is because you're pulling directly from NuGet. If you're trying to secure your software supply chain, you want to reduce your reliance on the public internet for your builds. Additionally, then the next one is pulling from your packages that are stored locally on your machine. And that's bad because then your other developers that you're collaborating with don't have access to the same packages that you have there. And the third reason why this is a insecure package source file is because you have multiple feeds listed in this package source file, which means that if you're calling an internal package that's not posted publicly, it's possible that you could be vulnerable to dependency confusion attacks. And so, the other thing I wanted to say about pulling direct from NuGet.org or any other direct public package, if you pull direct from there, you're leaving yourself vulnerable to what if that upstream maintainer decides to remove their package one day, which is what happened with LeftPad in 2016, and it broke the internet because everybody was just calling direct to the public package manager to pull down their packages, and if it's not there, then you can't build. So this is an example of a securely configured source file. This is one of our requirements in the framework. It's enforce it, number 1. And when we say enforce, what do we mean by that? In Microsoft, we actually mean we break the build. If you have an insecure package source file, we can detect that and fail your build to make sure that you are configured appropriately. So what we've done inside Microsoft is we have the NuGet.config file point to an Azure Artifacts feed, and Azure Artifacts has this really cool ability called upstreaming, where then you can point it to all the other feeds that you want it to, and it can actually do so in a deterministic way and call the feeds in priority order. And that way, we make sure that we are protected from dependency confusion attacks. And because I'm showing you a NuGet.config example, I also want to tell you that NuGet went ahead and wanted to protect all of their user community from dependency confusion attacks. so that if you're not set up in this kind of a way, you can actually start leveraging package source mapping as a new way to secure yourselves. So what did Microsoft do to I'm not gonna switch out, but okay. So what did Microsoft do to scan all of these things? We have internal gates right now where we can scan for typo squatting, for malware, quarantine, and we can do all of that as part of the normal ingestion workflow. And there are other tools and capabilities out there today. You can check out our implementation guide that recommends other tools for doing that. Yes.
Hi, quick question for you. Are there services that you can feed an SBOM into, will produce a feed for you when there are vulnerable dependencies, give you that immediate information about known exploits and, you know?
You are talking to the right people.
All right, great.
Software bills of material is something that our team works on. We've produced the SBOM tool that's now open source, but you're asking about the consumption side of that. There are, I would say, numerous open source generation tools, but when you start looking at consumption tools across the market today, a lot of them are like enterprise tools that require some sort of paid software license. There is an open source one. It's called Daggerboard. So go to GitHub and look up Daggerboard. It was produced by, I think, the Presbyterian Hospital, because healthcare organizations have been among the first to start adopting SBOMs. And for those that don't know, an SBOM provides software transparency. It's a machine-readable file that says, here's all the open source that I'm using inside this version of software. And you're supposed to have one SBOM for every version of software. And so SBOMs are rather new to the software industry at large. And we're all going to mature and get better at it over time. It's going to be a new practice that's going to become commonplace in the near future. And so yes, so those consumption tools, what they do is they look up the vulnerabilities of the OSS components inside of the software that you have deployed in your environment. So now you have visibility into your supply chain risk. That way, when the next log4j happens, you can look to see, am I affected and what is affected? You as a software consumer can't patch log4j. You have to wait for your vendor to patch it and ship you a patch that you then deploy into your environment, right? So what you can do then is do a risk assessment to understand, am I affected by log4j? Okay, so where is that piece of software in my system? Are there already like architectural risk mitigations that reduce the risk of compromise for where I have that piece of software deployed in my enterprise? And then you can be on the lookout for a hotfix or a VEX file. And a VEX file is something that will say, this vulnerability is not exploitable in our application because of reasons. Like we didn't implement that particular vulnerable function, or we didn't include that piece of code, and VEXs are even newer than SBOMs. So like this is cutting edge stuff. I think the world has to figure out those workflows, and Microsoft is absolutely trying to lead in that space, and happy to talk more about that later.
So we have about 5 minutes left, so we'll get a couple more questions.
Hi, are there plans to update and add security into like the Azure DevOps and GitHub Actions starter templates?
I would say that inside Microsoft, we are working on those sorts of things, and so it's just a question of are they useful? Are they productive? Is there a demand for it? Those are things that we have to assess over time and make sure the user experience is right before we ever consider bringing something like that forward.
Hey, so if I interpret level 4 of the maturity correctly, right? You're saying that we need to download the source code of all OSS and basically rebuild it ourselves. Do you foresee that will become like a standard feature for any privately hosted repositories to just do that automatically and manage that for you?
Yeah, so there's a lot of interesting stuff that's happening. We just to remind everybody, we think that level 4 is largely aspirational because that's very, very hard to do at scale. Like think of Microsoft. We consume 88,000 unique packages. How are we going to clone all of those, the repos of all of those packages and build all of those packages at scale? What's interesting is that we're starting to see companies do stuff like that. So I think one of them is called Active State, and they're rebuilding, I think, Python. So if you wanted to subscribe to something that was already rebuilt for you, there are starting to become offerings out there that you can do. However, I think that there's some like critical projects that we can, where it's worthwhile to reduce the risk that a nation-state adversary may compromise an OSS during build time. And if you want to take the time and effort to reduce that risk, then level 4 is where you want to be. Making it simpler, I think, is definitely one possibility. Another possibility would be how can these open source ecosystems move towards reproducible builds and maybe automate that themselves in the background so that they could put check marks up there that say reproducibly built or something like that. But now we're just talking about like how awesome the world could be, right?
Okay, I think one more question in the room because we're getting them answered online from some of your team, Adrian and Jasmine. So last question in the room. Oh, right here.
So Dependabot is a very valuable tool, but not accessible to all organizations, especially if you're stuck with on-prem systems, government space, especially within that. Is there a architecture diagram or kind of model that Microsoft provides on how Dependabot was built so that could be recreated on those on-prem environments, kind of similar to how GitHub Actions or the Azure Pipeline agents are built?
That's an interesting question. I'm not aware personally of an architecture so that you could go rebuild it yourself and redeploy it. There are other options. I don't know if they work in on-prem environments, but RenovateBot is another open source one that's listed in our implementation guide. So that might be something you could explore as well. Yeah, I'm sorry, I don't have that knowledge or awareness that exists. Yeah, Dependabot was purchased by GitHub, and they have it natively integrated into all GitHub user workflows. Yeah.
Okay, well, we are at the top of the hour right now, so we'll say a huge thank you to Adrian and Jasmine. Fist bumps. Are you guys doing an Ask the Experts session after this? Do you know? Or will you be around? Okay.
But I will be in the expert booth in the DevSecOps area,
okay.
So you can come find me out there.
Awesome. And then Adrian and Jasmine, if you guys can go online for the folks on the call and maybe answer any questions there too. Thank you guys. Appreciate it.
Thank you, everybody.